Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
Every breath we take contains almost 78% nitrogen. It is everywhere around us. But the nitrogen used in industries is not simply taken from air and used directly. Factories need nitrogen with controlled purity, pressure, flow rate, dryness, and reliability. Nitrogen is used in steel, chemicals, food packaging, and electronics. But here is the interesting question. If nitrogen is already present in air, why do industries need huge nitrogen plants? And how do engineers separate it? Today, we will decode the complete engineering behind industrial nitrogen production. We'll understand how air is converted and how different separation units work. And finally, we will understand where modern electrolysis and electrochemical nitrogen technologies fit into the future of clean chemical production. So let's enter the world of industrial nitrogen manufacturing, starting with why this gas is so critical to our modern world. Nitrogen is called an inert gas in many industrial applications. It is much less reactive than oxygen, making it extremely useful where oxygen creates problems. Oxygen supports combustion, causes oxidation, reacts with metals, and spoils food. Nitrogen helps remove or reduce oxygen from the system. In industries, nitrogen is used for blanketing storage tanks, purging pipelines, food packaging to increase shelf life, and preventing explosions in flammable zones. Imagine a chemical storage tank containing a flammable liquid. If air enters, oxygen mixes with vapor, creating an explosive atmosphere. Nitrogen acts as a safety blanket, reducing that risk. Before understanding production, we must understand the raw material, atmospheric air. Dry air contains approximately 78% nitrogen, 21% oxygen, and 0.93% argon. But real air also contains dust, moisture, and pollutants. Nitrogen production is a complete purification operation. The plant must remove every single impurity. There are three major industrial methods for nitrogen production: cryogenic air separation, pressure swing adsorption, PSA, and membrane separation. Cryogenic air separation is the most powerful method for large-scale production. The word cryogenic means extremely low temperature. Air is cooled until it becomes liquid. Separation is based on different boiling points. Because nitrogen boils at a lower temperature than oxygen, it vaporizes more easily. Engineers use this inside a distillation column. The process starts with compression. High-pressure air is easier to cool, clean, and liquefy. But compression increases temperature, so the air must be cooled afterward. Condensate separators remove liquid water. This is critical. If water enters the cryogenic section, it will freeze and block the entire system. Next is the pre-purification unit, or PPU. It uses activated alumina to remove moisture and molecular sieves to trap carbon dioxide and hydrocarbons. Most plants use two vessels, one in service while the other is regenerated by heating. This continuous switching allows for uninterrupted industrial operation. The clean dry air enters the main heat exchanger. This highly efficient system cools incoming warm air using outgoing cold product gases. Energy recovery is at its peak here. To reach cryogenic temperatures, we need refrigeration. This is created by an expansion turbine where gas does work and its temperature drops sharply. Now the heart, the distillation column. Inside, liquid and vapor move in opposite directions. Nitrogen concentration increases at the top, while oxygen stays at the bottom. The nitrogen produced here can be extremely pure, reaching 99.99999%. This is why large steel plants and refineries rely on cryogenic separation. For smaller industries, we have PSA, pressure swing adsorption. This method doesn't liquefy air, instead it separates gases at normal temperatures using adsorbents. The key is carbon molecular sieve, or CMS. It has tiny pores that absorb oxygen faster than nitrogen, letting the nitrogen pass through as the product gas. PSA uses two towers. While one is producing nitrogen under pressure, the other is depressurized to release trapped oxygen. This rhythmic swing is where the name comes from. A typical PSA system includes a compressor, dryer, filters, and a buffer tank. Air quality is vital. Oil or water can destroy the adsorbent beds. Higher purity means lower recovery and higher energy. Engineers must select purity based on the actual application. Over-designing simply wastes money. PSA is compact, starts fast, and provides independence from tankers. It's the most practical solution for many modern factories. Finally, we have membrane separation. This uses hollow fiber tubes where oxygen and water vapor pass through faster, leaving a nitrogen-rich stream behind. Now, where does modern electrolysis fit? Traditional nitrogen isn't made by water electrolysis. That makes hydrogen and oxygen. But there are three critical connections. First, green ammonia. Hydrogen from electrolysis is combined with nitrogen separated from air. This is a massive future application for clean chemical production. Scientists are also researching electrochemical nitrogen reduction, converting nitrogen into ammonia at lower temperatures. It's a challenging but promising field. Which system is best? It depends on 5 factors: required purity, flow rate, pressure, demand patterns, and overall operating costs. A good engineer selects a plant by understanding the complete demand profile. Peak flow, purity variations, and maintenance philosophy are all critical for a safe design. Nitrogen is useful but dangerous. It has no color, smell, or taste. If it leaks in a closed room, it can displace oxygen, causing a person to collapse without warning. Nitrogen systems require proper ventilation, oxygen detectors, and strict training. Every plant must be treated with respect to ensure the safety of the workforce. Industrial nitrogen isn't just created, it's separated from air through precise engineering. From cryogenic distillation to PSA and membranes, it's a vital industrial utility. Nitrogen silently protects our products and people. If you learned something new, subscribe for more deep industrial engineering videos. See you in the next one.